A 3x3 table starts with every entry equal to 0 and is modified using the following steps: adding 1 to all three numbers in any row, adding 2 to all three numbers in any column. After step 1 has been used a total of A times and step 2 has been used a total of B times, the table appears as shown. What is the value of A plus B? We are trying to convert a 0, 0 table to this table right here. Okay, so the key, I think, is to concentrate in chronological order, meaning start with the smallest number and then work your way up. So the smallest number is a 1. So I'm going to use step A to turn that into a 1. So that is step A. Okay, I'm done with that. So now I've got to go in chronological order, so that's a 2. So let's do that. Let's convert that into eventually a 2, but I have to do it one step at a time. So that's an A. And then I've got to do it again to convert that into a 2. So this is done, that is done. Okay, great. Now what's next? And oh, forgot to put the fact that that was an A. Now I've got to concentrate on this 3. So I've got to add 1s 3 times. So it's going to be 1, 1, 1. The other 2 don't change. So that's an A. And then that 1, 1, 1 becomes 2, 2, 2. The other 2 don't change. And then eventually another adding 1 makes it a 3, 3, 3. Okay, now I am completed the middle column. So if I've completed the middle column, now I can just concentrate on the first column and the third column. And I'm going to do that by using this rule, the 2's, where you add 2 to the members of any column. So it doesn't really matter which one you start first. Let me just start with that one since I'm following chronological order. So if I start with this one, if I use the B step and adding 2, so that would become 3, 5, and 4. That stays 1, 3, 2. That stays 1, 3, 2. Okay, I got to do it again because I got to get up to 5, 7, 6. So if I add 2's again, it'll be 5, 7, 6. There you go. Okay, so now that is complete. That is complete. And then now I've just got to concentrate on the last. Oh, actually, it's the first column. Okay, now I've got to add 2's to that. If I do it once, it becomes 3, 5, and 4. 5, 7, 6. That's a B. And if I do it again, it becomes 5, 7, and 6. And if I do it one more time, meaning step B, it will become the 7, 9, and the 8. And there you go. So I've completed it, and now I've got to count how many A's I did and how many B's I did. So the A is 1, 2, 3, 4, 5, 6 A's, and how many B's? 1, 2, 3, 4, 5. 5 B's. So therefore A plus B is 6 plus 5, and that is 11. 4 distinct integers a, b, c, d are chosen from the set 1 through 10. What is the greatest possible value of ac plus bd minus ad minus bc? Okay. Before we tackle that, we'll probably need to manipulate it a little bit because currently it doesn't have that obvious of value. So let me first group the a's together, and then I'll group the b's together, and then I'll do some factoring. When I factor, I will get c minus d. Here, when I factor, I get d minus c. Okay. The c minus d I'll keep, but this one I'll flip the negative, so it'll be c minus d, and that will allow me to factor the c minus d, and then I get a minus b. Okay, that is a good way of looking at it, this one right here. So now I want to make this as big as possible using those numbers. Okay. Well, it looks obviously like two numbers multiplied by each other. So c minus d, how do I make that as big as possible? If I use 10 for c and 1 for d, that becomes a 9. But, oh, they're distinct. Ah, okay. Since they're distinct, I can only use each number once. So the 10 and the 1 are gone. So if I use, therefore, 9 and 2 for a and b, that will be a 7. 7, therefore, 9 times 7, and that's 63. Okay. Is that the greatest, or can I get a bigger value? Let's see. Instead of 10 and 1, let's see if I use 10 and 2 for c and d respectively, and therefore that would become an 8. And instead of 9 and 2, if I use 9 and 1, then that becomes an 8. Now I have 8 times 8, and that's 64. 64 is greater than 63, and that is indeed the greatest possible value of that original expression. In the diagram, ABC is right-angled at C, point D is on AB, and point E is on BC, so that DE is perpendicular to BC, BE is equal to AC, BD is 120, and DE plus BC is 288. What is the length of DE? All right, so let's explore this question in a thorough way. I am confident that there's a shortcut, but I want to explore it in a thorough way since you are practicing, and it always helps to explore something in a thorough way during practice. Now, during the actual exam, if you find a shortcut after seeing this full solution, then that's ideal. So here we go. A couple of labeling here. I'm going to make a line that goes straight across like that. That's perpendicular. Let's see here. I'm going to label this x, and therefore, according to the question, that side is x, right? Because BE equals AC. And then this side I will call y, therefore that is also y, just that segment. And then this I'll call z. That they've told me is 120, and I think that's it. And then this is a right angle just for the sake of completion. And I think that segment is x minus y, that little guy that from there to there. Okay, I think that's about as good as I can get in terms of labeling. And then based on the question, x plus y plus z is 288. And that's really this guy, DE, which is y, plus BC, which is basically BE plus EC. Okay, and then using similar triangles, x minus y, this is z right here, over z is the same as the full x, the same as y over x. So really what I've done is I've compared this triangle to this triangle DBE, and they have the same angles and therefore they're similar. So if I cross multiply, I get x squared minus xy is equal to yz, and therefore x squared is equal to xy plus yz. Okay, so that's actually a pretty decent setup to the question. So here we go. Using Pythagoras on triangle DBE, I'll get x squared plus y squared is equal to 120 squared. And then this equation I will square, x plus y plus z, I'll square both sides. And the reason I'm doing that is because I've got some squares there, so I've got to have some squares there as well. And if you expand that, you will get x squared plus 2xy plus 2yz plus 2xz plus y squared plus z squared, and that's 288 squared. Okay, so that is pretty decent because that x squared plus y squared is 120, so I can just put that in. And then these ones I think I will factor somehow. I'm just trying to see how. Xy plus yz, I'll factor that guy, and this one I'll just keep alone, and then the z squared for now is not much I can do. Okay, so at this point we have xy plus yz. Well, I knew there was some use for that. This guy is x squared, so I've got 120 squared plus 2x squared plus 2xz plus z squared is 288 squared. Okay, that's actually pretty good. And then now at this point, on the side here, just in case it's not intuitive, I want to write out what is x plus z squared, just the algebra of it, just to remind you that it would be that, right? And that looks very similar to this, but it's only similar if you break up that x squared into 2 like that. Then it becomes like that. So then that becomes 288 squared. So then now this guy we can factor 120 squared, x squared, and then that guy becomes x plus z squared. Got it? X plus z squared. Okay. Get moving right along here. And then if you go back to the original triangle, x squared plus x plus z squared, this is x, that whole side. X plus z is that whole side. That, therefore, by Pythagorean theorem, is ab squared. The hypotenuse all squared. So that's a very, very good finding, right? That helps you figure out what is BA. And then I will let you figure out BA. It's not that hard. BA or AB, however you want to call it. If you want to call it BA, that's fine. When you crunch out those numbers, you'll be able to get that it's equal to 261.81. Okay? And then we are told that D to B is 120. So AD, let's see if I can keep it in the same, AD, therefore, would be BA minus that 120. So AD is going to be 141.81. Okay, so we're almost done. Even though I've done it in a very thorough way, we're almost done. So now finally we go back to this similar triangle situation. I think I can keep it in the same screen. That x over y is the same as BA over BD. Now you say, well, why is that? Using similar triangles. So for example, I'm using the big one, this big triangle, this side x over the hypotenuse, which would be AB or BA. So here's my x and here's my BA. And then the small triangle, which is just the DEB guy, that one, it would be y over the hypotenuse, which is BD. And that's why I get that similar triangle relationship, in case it wasn't that obvious to you. Okay, so well, x over y, well, BA and BD we have. BA we have as 261.81, and BD we figured out, well, I don't know, BD is given in the question, 120. So then this will give you a relationship of x is equal to 2.18175y. And then finally, now we go back to our original equation right there. X squared plus y squared is equal to 120 squared. And then you can solve for y, which is the length of DE, that one right there. So if x is 2.18175y, plug that in, and there you go. Now you've got everything in terms of y, and you can solve. And that would be, let's see here, 4.76y squared plus y squared is equal to 120 squared. 5.76y squared is equal to 120 squared. And therefore, when you do this, you'll get y squared is equal to 2500. And therefore, y is equal to 50. Y was representing DE, so DE is 50. So as you can see, I did it in a very thorough way. I wanted you to see the whole solution. If you can come up with a shortcut, then that's wonderful. I encourage you to do so because the time on the math contest, as you know, is limited. The integer n is the smallest positive integer. That is a multiple of 2024. Has more than 100 positive divisors and has fewer than 110 positive divisors. What is the sum of the digits of n? N is some multiple of 2024. So 2024 times some k. And therefore, we want to break this up into its prime factors. So if you do, it'll be 2 to the power of 3 times 11 to the power of 1 times 13 to the power of 1. And then we have this k, and I have no idea what k is. Now let D be the number of divisors of n. And they're telling us that D is between 110 and 100. Okay? Now, you guys remember a rule, right? Like, let's say you have an integer and you have it broken down into its prime factors. So first prime number to some power, second prime number to some power. The number of divisors, this is a cool little formula, some of you know it, is a plus 1 times b plus 1. So for example, if I gave you a number like, if I gave you the number and then you broke it into its prime factors, and it was something like 11 to the power of 3 times 13 to the power of 4. And remember, these have to be prime numbers, just like they're prime numbers up here. And I said to you, how many divisors does n have? Well, instead of doing the long way, which would take forever, you just take the 3, add 1, take the 4, add 1, and there you go. So that's 4 times 5, which is 20. So similarly with this, the number of divisors, d is, it depends on n. So for example, if n is, you got your 2 to the power of something, 11 to the power, I'm just going by this, a2, 13 to the power of a3, and then we don't know what k is, so it could keep on going. The number of divisors would be a1 plus 1 times a2 plus 1 plus a3 plus 1, and so on, depending on what k is. You got it? So that's the original setup of the question. Now, we can see that d, just from this equation, it has to be the product of at least 3 numbers. So it has to be the product of at least 3 numbers, right? Here's 1 number, here's 2 numbers, here's 3 numbers. It could be more, but we know at least 3, because we are unsure what is that k. That's the big mystery in this question. And also, these numbers are greater than or equal to 2. Yeah, because if the exponent is 1, for example, that would become 1 plus 1, which is 2. And so those numbers have to be at least 2. You can't have a 1 in there. Okay, so they have, in a very helpful way, I think, given us a small range for d. So that's helpful, because otherwise the question becomes extremely time-consuming. So d is between, is it inclusive? No, it's not inclusive. So it's 101, 102, 103, 104, 105, 106, 107, 108, or 109. Those are the only possibilities for d in that range. Okay, so now we're going to look at that very important point. Well, 101 is a prime number, so there's no way you can make it the product of 3 numbers like this. Yeah, well, at least 3 is actually the way of looking at it. So that one's out. Okay, that's good. Are there any other prime numbers in here? 103 is a prime, so that's out. 107 is a prime, so that's out. And I believe 109 is also prime. So that's good. We're narrowing it down. Also, 106, that is 2 times 53, and 53 is a prime. So there's no way you can make 106 the product of at least 3 numbers. Well, you could put a 1 there, but all 3 numbers have to be greater than or equal to 2. So that falls apart. So 106 is out. So therefore, through process of elimination, the only possible values for d are 102, 104, 105, and 108. 102, 104, 105, and 108. Yeah. Okay. All right, let's work with this now. Yeah. Okay. Well, before I work with it, I'd like to break these up into their prime factors. I think that will help me. So what is 102? It's 2 times 3 times 17. 6 times, yes. What is 104? It's in terms of prime factors, 2 to the power of 3 times 13. 105 obviously is 5 times 30, 5 times 21. So it'd be 3 times 5 times 7. And then 108 is 2 to the power of 2 times 3 to the power of 3. 4 times 27, right? Yeah. Okay. Now I can concentrate on trying to figure out the question. So the good news is I've only got 4 values of d to work with. Okay, so that makes the question less time consuming, but I still think it's challenging. I don't think it's that straightforward, at least for some of these guys, because there's going to be multiple possibilities for n, and that's what makes it challenging. If each value of d only gave one value of n, then it'd be fairly straightforward, but unfortunately that's not the case. Okay, so here we go. So if d is 102, then that means that n would be 2 to the power of something, 11 to the power of something, and what was the other one? 13, right? Yeah, 13 to the power of something. But then we've got to create a situation where this has to match. Okay, I got it. So 2 times 13 times 17 is this guy right here. So it's a plus 1 times a2 plus 1 times a3 plus 1. Yeah. Okay, and we are always looking for the smallest. Okay, that's a very important thing that I reminded myself of. N's got to be as small as possible. So to get n as small as possible, I'm going to make the big one a power of n. So I'll put the 17 here. I'll let this be the 17. And did I do this? Oh, sorry. Yeah. Yeah, no, that's right. Second guessing myself here. Yeah, that's right. Okay, and then the 3, I guess, following the same fashion, put the 3 here, and then let the 2 go there, since that's going to be the exponent related to the 13. So then if a plus 1 is 17, then a1 would therefore be 16. So the 16 would go here. And if the a2 plus 1 is 3, that means a2 is 2, so that 2 goes here. And if the a3 plus 1 is 2, that means a3 is 1, so therefore that goes there. So 2 to the power of 16, 11 to the power of 2, and 13 to the power of 1. And when you crunch out that number, it's 1, 8, 2, 3, 8, 6, 6, 8, 8. So that's huge. So my gut instinct is that that is not the correct answer. Okay, no problem. We got to keep going here. D equals 104. Okay, so D equals 104. 104 is this guy. 2 to the power of 3 times 13. And that's A1 plus 1 times A2 plus 1 times A3 plus 1. Yeah. And, and remember we had a K there. Yeah, so it could be another one. And the reason is because each of these D's is not going to give you only one N. Sometimes it can give you more than one N. Well, I think it can give numerous. And we're concentrating on getting the smallest one. So if first of all, I've only got 2 numbers here, and here we got 3. So I got to break up that 2 to the power of 3. So for example, if I denote that to be 13, the A1 plus 1, and then 2 to the power of 3 is 8. So then I've got to break that up, let's say 4 and 2, let's say. So if I gave this 4 and that 2, that kind, you see what I mean? There's lots of ways. So the way to do it in terms of making it the smallest n possible is to add a 4th prime. And then break it up into 2, 2, 2. So that's 2, and that's 2. And therefore A1 would be 12. A2 would be 1. A3 would be 1. And A4 would be 1. And then therefore n would be 2 to the power of 12 times 11 to the power of 1 times 13 to the power of 1. And then remember we got another one. So we got to put another prime number in here to the power of 1. And since we want the smallest value of n, I'll choose the smallest prime that has not been chosen yet, and that's 3. And that's the smallest prime you can make with D equals 104. And that is 3108864. So as you can see, it's not as simple as we had hoped, at least I had hoped, because each D is giving multiple possibilities for n, and I've got to choose the smallest possible n. Okay, we're still not done. We still got a couple more. So 105 for D. 105 for D. That's 3 times 5. 3 times 5 times 7, correct? Yeah. So 3 times 5 times 7, and that is my A1 plus 1 times A2 plus 1, and then A3 plus 1. So I will do the distribution as follows. I will let this equal 7, that equal 5, and that equal 3. Therefore, my A1 is 6, my A2 is 4, and my A3 is 2. So therefore, the n is going to be 2 to the power of 6, 11 to the power of 4, and 13 to the power of 2. And that n is 495,685,696. Finally, with d equals 108, that one, we've got 108 is what? 2 to the power of 2 times 3 to the power of 3, and that is A1 plus 1, A2 plus 1, and A3 plus 1. And for this one, just like we did with 104, we're going to have to add another prime to minimize n. And this is how we're going to assign it. We're going to put 9 here. We're going to put 2 here, 2 here, and 3 there. So that distributes these guys. So therefore, A1 becomes 8, A2 becomes 1, A3 is 1, and A4 is 2. And therefore, our n would be 2 to the power of 8, 11 to the power of 1, 13 to the power of 1, and then some other prime to the power of 2. And I will choose the smallest prime since I want the smallest n. And the smallest prime is 3 of the ones I have not chosen yet. And that n is 582,912. And there we go. We've completed the question. And of all the n's that we can get, I've tried my best to get the smallest n for each d. And of the 4 smallest n's for each d, the smallest of those is this guy. And the sum of the numbers, therefore, which is what we're trying to figure out, is 5 plus 8, which is 13. 13 plus 2 is 15. 15 plus 9, 24. And 24 plus 3 is 27. So 27 is the answer to this very difficult question. A sequence of 11 positive real numbers, A1 through A11, satisfies A1 is 4 and A11 is 1024. And A1 plus AN minus 1 is equal to 5 over 2 square root of AN times AN minus 1 for every integer, with n between 2 and 11 inclusive. For example, if n is 7, A1 plus A6 is 5 over 2 times the square root of A7 times A6. There are S such sequences. What are the rightmost 2 digits of S? So we have A1 all the way until A11. And they only gave us the values of the first and the last. So they told me that this is 1024 and this is 4. Now, how do I get the values of A2, A3, and so on? Well, that's where that equation comes in, that equation that they gave me right here. Okay, so, and that equation is valid for all the n's from 2 to 11, I guess. Okay. So first step, let's make that equation a little bit more digestible by letting an equal to x and an minus 1 equal to y. So when I do that and I plug it in, I get x plus y is equal to 5 over 2 times the square root of xy. Now I'll square both sides. I'll get x squared plus 2xy plus y squared is 25 over 4 xy. Put everything on one side, collect like terms, that kind of thing. Multiply through by 4 first of all to get rid of that fraction. 8xy plus 4y squared, 25xy, and then put everything on one side, and we get minus 17xy plus 4xy, but 4y squared I should say. Okay, and at this point I think you can factor very well. 4x, x, y, 4y, minus minus. So that means that 4x is equal to y, or x is equal to 4y. So that means that x is either y divided by 4, which basically means, if you go back and look at our initial terminology, that an is equal to an minus 1 divided by 4, or it means that if x is 4y, then that means that an is equal to 4 times an minus 1. Okay, that's pretty good. So what does that actually mean? That means that as you're making these jumps, you're going from this to that, then that to that. See, each number will lead to the next number, like this. How you decide is with these two formulas. So, for example, a2 would be either a1 divided by 4, or a2 would be 4 times a1. We got two choices. So, for example, let's give one such scenario. a1, a2, let me write those in. a4. This is just one example to illustrate how you'd go and figure out what these numbers are. Okay, so I've got 4, right, for a1. Now I want to go to a2. Let's just use a2 equals 4a1. Let's just keep using that until we exhaust it. So a2 would be 4 times that, so that'd be 16. And then let's just keep using that same rule again, 16, so 64. Then again, 256. And then again, 1024. Oh, the problem is that 1024 is A11, so I can't keep going with that rule because then I'll just keep getting bigger. So now I'm going to switch my attention to this rule where, well, not so specifically A2, but this guy. Where is it? This one right here, where an is an minus 1 divided by 4. So that, in our specific condition, would be a6 is equal to a5 divided by 4. Got it? So if that's the case, this becomes 256. And then we can flip-flop between this rule and that rule. We can make it 4x, which would be using this rule to make it 1024. And then we can make it this rule, divide by 4, 256. And then 1024, and then 256. And then finally we do get to 1024. Okay, so that's great. That's a perfect example of just one such way. How many is the total? Well, what did I actually do here? I used the 4x rule here, 4x rule, 4x, 4x. And then I used the x over 4 rule here. And then from there to there, 4x. And then x over 4, 4x. And then from there to there, x over 4. And then from there to there, 4x. Okay. So how many times did I use the 4x rule? 1, 2, 3, 4, 5, 6, 7 times. And how many times did I use the x over 4 rule? 1, 2, 3. Okay. So to go from 4 to 1024 over the course of 10 steps, I would have to use the 4x rule 7 times and the x over 4 rule 3 times. Now the question is, how many ways can you do that? Okay, that's fairly straightforward. From the 10 steps, we want to choose 7 to be 4x. And then from the other 3 steps that are remaining, choose all 3 to be x over 4. The mathematics of that would be 10 choose 7 times 3 choose 3. 10 choose 7 times 3 choose 3. Well, 10 choose 7 is 10 times 9 times 8 over 3 times 2 times 1. And then 3 choose 3 is just 1. And then 10 times 9 times 8 over 6 is 120. And that is S. And they want the right two most digit of S, which is 20. So therefore the answer to this question is 20.